Hello everyone, today we are going to explain how semiconductors are made. The manufacturing process of semiconductors involves several complex steps. Let's discuss 11 simplified steps of how semiconductors, specifically silicon-based integrated circuits, ICs, are made. 1. Silicon ingot growth. The process begins with the production of a silicon ingot. Highly purified silicon is melted in a crucible and then slowly pulled upwards, allowing a cylindrical crystal structure to form. This crystal is called a silicon ingot. 2. Wafer slicing. The silicon ingot is then sliced into thin, circular discs called wafers using a diamond saw. These wafers typically have a diameter of 200 mm or 300 mm. 3. Wafer cleaning. The wafers undergo a series of cleaning steps to remove any impurities or contaminants from their surfaces. This ensures the quality and purity of the silicon material. 4. Photoresist coating. A thin layer of photoresist material is applied to the surface of the wafer. Photoresist is a light-sensitive material that will be used to define the circuit patterns on the wafer. 5. Photolithography. Photolithography is a critical step that defines the intricate circuit patterns on the wafer. A photomask, which contains the desired circuit pattern, is placed over the wafer. Ultraviolet, UV, light is passed through the photomask, exposing the photoresist. The exposed areas of the photoresist either become soluble or insoluble, depending on the type of photoresist used. 6. Etching. The wafer is immersed in a chemical solution or plasma, which selectively removes either the exposed or unexposed parts of the photoresist, depending on whether positive or negative photoresist is used. This etching process transfers the pattern from the photoresist onto the underlying silicon surface. 7. Dopant implantation. Dopants, such as phosphorus or boron, are introduced into specific areas of the silicon wafer to alter its electrical properties and create regions of different conductivity. This process, called ion implantation, involves bombarding the wafer with ions of the desired dopant material. 8. Thermal annealing. The wafer is subjected to high temperatures in a process called annealing. This helps to activate and diffuse the dopants, making them electrically active and creating well-defined conductivity regions. 9. Thin film deposition. Additional thin films, such as silicon dioxide, SiO2, or metal layers, may be deposited on the wafer using techniques like chemical vapor deposition, CVD, or physical vapor deposition, PVD. These thin films are used for insulation, interconnections, and other purposes. 10. Metallization. Metal layers, typically aluminum or copper, are deposited on the wafer's surface to create interconnections between the different components and circuit elements. 11. Testing and packaging. The completed wafers undergo rigorous testing to ensure their functionality and performance. After testing, the individual ICs on the wafer are separated through a process called dicing. Each IC is then packaged in a protective casing, which provides electrical connections and safeguards the IC from external influences. The above steps represent a simplified outline of the semiconductor manufacturing process. The actual fabrication process involves numerous additional steps and intricate details. Advanced techniques, such as multiple patterning and three-dimensional, 3D integration, are also employed to create increasingly complex and higher-density integrated circuits. Thanks for watching and catch you on the next.